Welcome back, everybody. Just wanted to now work on our last questions from the medians of a triangle homework number 7. And so these are, again, a little more tricky. So let's see, question number 6, rectangle ABCD has diagonals BD and AC intersect at E. Point F is located at the midpoint of side CD, and segment AF intersecting diagonal BD at point G, as shown. It is known that BC is 18 and CD is 24. We want to find GE. So a couple of things. We always want to label our diagram. So we're going to now label BC as 18. And we'll label, in this case, CD as 24. That would mean, in this situation, that because we know that our rectangle has all right angles, well, all the angles are right angles, angle BCD is a right angle, we can use Pythagorean theorem to find BD, the hypotenuse here. And so we'll do, in this case, 18 squared plus 24 squared is equal to BD squared. Okay, so we know 18 squared should be 324. And in this case, a 24 squared, I believe, is 576. And is equal to BD squared. And so we add this together and we end up with the number, it looks like in this case, 900. 900 is BD squared, which if we take the square root of both sides, we should get, in this case, 30. So BD is 30. Okay, so that's important information. Now you might say, why is that important? Well, a couple of things. We also know, but properties of a rectangle, that the diagonals are congruent and bisect each other. So if we know, in this case, BD is 30, we should also know that the measure of DE is congruent to BE. So each is going to be 15. And since we're looking for GE, we definitely know that GE is part of DE, so we're going to know that GE has to be less than 15. So we have that going for us. Now, the question is going to be, okay, well, how do we find EG? Well, remember the topic, ladies and gentlemen. It is medians of a triangle, and the triangle we're going to be focusing on will be triangle ADC. Now you're saying, what do you mean? Well, we know that the diagonals bisect each other, therefore E is a midpoint, and we know F is a midpoint here as well too. So that would mean that DE and AF are medians, and that G is a centroid, the centroid of the segment. So you're saying, okay, well, we should then know that since G is a centroid, that the ratio of DG to GE is going to be a ratio of 2 to 1. Please remember that a median divided by the centroid breaks the segments in a ratio 2 to 1 from the vertex to the centroid, from the centroid to the midpoint. So DG to GE is 2 to 1. But we also know that DE is going to be 15. So we'll make this 2n and make this 1n. So we know 2n plus 1n equals the full length of the segment, which is 15. Therefore, 3n equals 15. N is equal to 5. So that tells us in this case, since G is 1n, GE, so GE is 1n, GE is equal to 5 units. Okay, all right. So that helps explain here our situation for question number 6. Now let's go to question number 7. Now question number 7 says AE is 1/3 of AC, and ED is parallel to CB. Explain why DF must be 1/4 the length of CD. Okay. Well, if ED is parallel to CB, so we know these are parallel, we also know that in this situation that the triangles triangle AED is going to be similar to triangle ACD. All right, and then not only that, we also know in this case that the ratio of sides are going to be proportional. So we know that in this situation that AE to AE is 1/3 of AC. So in this case, this is 1N, and this will be 3N. All right, so why is DF 1/4 of the length of CD? Well, okay, so let's now take a look at this. Well, we do know that the ratio of sides of this should be 1 to 3. So this would be in this case also DE to, so the ratio of DE to CB, ratio DE to CB is also 1 to 3. So okay, all right, that's not such a big deal. But then we want to know why is DF 1/4 of this here. So so we want to take a look here, and we see that for the triangles, well, the triangle FDE and FCB are going to be similar to each other. And so say, well, how come? Well, if those line segments are parallel, if in this case ED is parallel to CB, that would mean angle EDF and angle DCB are congruent, because in this case, alternate tier angles of parallel lines are congruent. The same thing for, in this case, angle DEF and angle FCB, FBC. Again, for the same reason. And so we know the triangle is similar. So now we say triangle FDE is similar to triangle FBC. Okay? So now, okay, well, triangles are similar. We know that the ratio of sides are going to be proportional. So we know here that that in this case, that DF to FC is equal to DE or ED to CB, which in this case is a ratio of 1 to 3. So okay, well, it's still trying to figure out, why is DF 1/4 of CD? Wait a minute. We see here that if we call DF is 1, we'll call 1x, and FC is 3x, that would mean that DC, so if DF is 1x and FC equals 3x, that would mean that the add them together, your sum in this case of CD would equal to 4x. Now, that being the case, the ratio of DF to CD is 1x to 4x. Hey, there goes our ratio of 1 to 4. Okay? And so it was a matter of showing that the triangles are going to be similar to each other. The reason for a triangle AED, similar triangle ACD, because if a line segment intersects two sides of a triangle and is parallel to the third side, the new triangle form is going to be similar to the original triangle. And then from there, we know corresponding sides are going to be proportional to each other. And so we know here that our ratio of sides, in this case, again, ED is going to be, we know ED is 1/3, 1N, and 3N. Very similar ratio here. Not necessarily the same values, but the same ratio of 1N to 3N. We can use that to help us figure out the second pair of triangles as similar. Triangle FDE, similar triangle FBC, because when you have parallel lines, the alternate angles formed are going to be congruent to each other. So that from there we can prove the second pair of triangles similar. Use the proportion we see of, in this case, DF to FC, same ratio is equal to the same ratio of ED to CB, which is 1 to 3. We are going to calculate that DF is 1x and FC is 3x, therefore CD, the whole segment, must be 4x, and therefore comparing DF to the whole segment CD is going to be a ratio of 1 to 4, 1 to 4, or 1/4. So we would say in this case that, that here DF is going to be equal, so that DF must be 1/4. DF is equal to 1/4 of CD. We multiply both sides here by CD though. Okay, so that was a very involved problem. Now, when you guys hand in your work, please make sure to write out the reasons for triangles similar. I write them all out on the screen, but it's already super messy. In any case, if you found these questions helpful, please hit the like button and subscribe to the channel so you get updates for any new content. We're doing our best, ladies and gentlemen. I hope you guys are safe, and I look forward to seeing you in the next video. Take care.